Hi and welcome, this is Rocket Stove version 2. This is an image of the J-bend construction. The pipe was cut to 45 degrees. And this is just an image of the welded J-bend once it's been completed, weld all the way around it. The base was trimmed on the outer case. This is where the J-bend will fit inside. Just so you don't cut yourself, the J-bend was measured beside the outer case. This gave me the position for the J-bend intake hole, which was then cut using a plasma cutter. The outer case was measured to size. I allowed for the J-bend to protrude through the top by 20mm. This would allow me to fit a cap to the top. The cap for the stove was cut. I used a plasma cutter to cut the cap. The cap was fitted, allowing for the J-bend to protrude. The J-bend was then tacked into position, and perlite was added as a thermal insulant. This would stop the heat from escaping from the J-bend and allow for better boiling times. The cap and the remainder of the rocket stove was fully welded, and then a test was performed. It ended up taking 30 minutes to boil 2 cups of water. It's just a good test to see how efficient your rocket stove is. This was an improvement on my last attempt, rocket stove version 1. It took me 35 minutes to boil 2 cups of water. Overall, I have learnt that J-bend rocket stoves are inefficient for what I need, so it's back to the drawing board. Rocket stove version 3 is coming soon. Thanks for watching. Final notes: J-bend rocket stoves are good at generating good heat with very little fuel input. The biggest downside is the time it takes to do something useful with this generated heat. However, if you have only a very small amount of fuel, then this is a very fuel efficient rocket stove version. Simply put, J-bend rocket stoves are very fuel efficient. They are not very time efficient. Cheers!